Hey folks, welcome back for another episode of Code Club. Good morning, I'm Pat Schloss, and I will be guiding you through today using our ggplot2 and other tools from the tidyverse to recreate these four panels from a figure that was published in the journal Nature Microbiology a month or so ago. As we get started here, I would love it if you could use the chat function to tell us where you're coming from and just to drop a line to say hi. Also, if you notice any other problems with audio or visual or whatever, other than my great looks, please feel free to make a note of those in the chat. As I said, I am going to be trying to build these panels B, C, D, and E from a figure that we have actually been talking about for the last 2 weeks or so. Last week on the live stream here, I made panels F and G, and there was interest in seeing how I would do panels B through E. I think the plots in this paper were really outstanding. That doesn't mean that there aren't things that I would change or that things that I wouldn't want to play with a little bit, right? And so we'll come back to the plot here in a minute, but I want to give you a little bit of context for the discussion we've been having. And so if you're not already a subscriber to my mailing list, I would really encourage you to go over to riffomonas.org, which I will put in the chat here. And you can, of course, subscribe to the mailing list. And so basically every Friday, you will get an email from me describing some data visualization that I have found, and then explaining how I would go about recreating that visual from a pretty high level. And so what does that look like? That looks like this. And so this is kind of the web-based version, but this is something that I published last week, talking about how I would go about recreating these four panels, B, C, D, and E. And as you can see, there's not really any code. There's a little bit of code maybe, but just kind of telling you what functions we would use or how we might do things like making things superscript or things like that, right? This also reminds me to tell you all that on January 9th from 1 to 4 p.m. in the afternoon, I will be hosting a virtual workshop talking about data visualization. And so if you hear me do critiques of data visuals and you want to know, well, how does Pat do that? How does he know these things? Or what are the things he looks at? This is the workshop for you. There is no coding involved in the workshop, but it's trying to get you to think like a designer, like a critic, not a negative critic, but as a positive critic, right? To think about the context in which these data visuals are made and what elements perhaps help or hinder from the author's ability to tell their story using data. I will go ahead and put the link to this mailing list here in the chat. And I will also click to learn more and give you the link to the workshop as well. And I've had a couple people already sign up for the workshop, and I would really love to have you join as well. So as I mentioned, thinking about critiques, let me go ahead and remind you of this video that I made, probably 2 Mondays ago, critiquing the overall figure that we had here in panels, really A through G, in the context of the overall paper. And so again, what I'm showing you here is part of the PDF. The original article is called Strain Displacement in Microbiomes via Ecological Competition. First author was Eric Baccarin, and the senior author was Kevin Forrest. This was work done by a group at the University of Oxford in the UK. Eric Baccarin, I believe, is now at the University of Calgary. And so if we come back to figure 2, and I want to just briefly mention some of the critique I had. And so let me just acknowledge you all. Thank you for shouting out. We've got Inlanez Saz from West Virginia, or Hassan, sorry, from West Virginia. Saeed, again, from Somalia. Mike from the UK. Nick from Greece, wonderful. Great to have Lori in Saskatchewan, Canada, where I'm sure is far colder than it is here. We've got Fabian from Germany, and Patrick from Kenya. And yeah, so wonderful. Great to have you all joining in. Thank you so much. So again, thinking about this figure, one of the critiques I had was that, again, the context of the figure is important to keep in mind, that many people still read the figures as part of a PDF. I do that, right? I printed out the figure as a PDF, right? So that I could hold it and look at it and kind of thumb through back and forth, and I can highlight things, and I can consume it, right? I realize we are living in a digital world, but I still like the physical. Anyway, so that being said, this is the full width of the PDF. And so one thing that stands out to me is that this figure uses the entire page, right? And that's fine. Like, who cares? Electrons are cheap, paper's cheap. But there's a whole lot of space on the right side here and on the left side here that's not being used. And so that doesn't happen so much in this figure, at least for like panels F and G, but it can tend to cram things together. And so one of my critiques of panels B through E, though, was that there's actually many points being shown here that are stacked on top of each other. And so I don't really know how many points are here. It looks like there's 3 at this cluster of points in panel B right above my cursor here. It looks like there's 3 and maybe 3 here. Are there? Over here, it looks like there's maybe 4 or 5. How many are there, right? And so what you notice if you come down to panels F and G then is that the points are actually jittered. They're not on top of each other at a common time point like they are up here. And so one idea I had that I wanted to play with in this episode is to jitter the points in panels B through E so we can better see how many points are actually there. One other thing that this gets me thinking about then is that the x-axis here is a little bit deceiving. I don't want to be too harsh on them because I do like this paper, but the number of hours between 8 and 24 is 16, right? And between 24 and 48 is 24, and 48 and 72 is 24, right? So one of those numbers is not like the others. So this position should correspond to 0, right? Because 0 to 24 is 24 hours, right? And so the 8 should be over just a smidge. And I don't think the placement on the x-axis in this case of that first time point is going to undercut the story they're telling. By no means does it do that. But it's not honest in a way, right? And I think there are other cases where people do this type of thing where it has like a very significant impact on how you interpret the figure. And so I want to talk about how we would fix that. The other critique I had here was that they had time points in hour. I think it should just be time in hour. And on the y-axis, they put the unit, CFU per mil. I liked how they did the CFU and then the ml with the -1 superscript. But this is a unit, right? And so that would be like on the x-axis, just putting h. And we wouldn't do that, would we, right? So on the y-axis, I'd like to put like density CFU per mil, okay? One other critique that I had of this visual that I want to take on today is that the legend down here is between panels D and E and F and G, even though it's the legend really for all 6 of these panels. And so one thought I had would be to take this legend and use some of the space that we have on the right side to make it easier to see, because it's really buried in these 6 or 7 panels, right? So if we could put it over on the right side, we could perhaps use some of that space as well to then highlight the legend, okay? Great to have you, Brian, joining from Iowa State. Wonderful. And so that's my task. I would like to be able to make panels B through G with you today to kind of put it all together. We already did F and G last week. We'll see how far we get. I don't want these to go too long. And so just to remind you, what we did last week, where are you, was right here. And so I'm going to go ahead and copy and paste this into the chat so you can go find that video. And you'll notice that at the bottom of that blog post, I have all of the code that we generated, okay? And so you can play with that as you want and perhaps adapt it to your own needs, right? And I thought that we did a pretty good job of recreating that in the last episode. Let me show you what F and G, the original and my version looked like. So that's a little bit too wide. And so this is the original and this is mine, right? And so again, you can see that I widened things to use the full width of the paper and to kind of give some more space. And but on the whole, I think I did a pretty good job of recreating these 2 panels, okay? And so again, if we have time, we'll see how we can bring this onto the bottom of the plot for B through E, okay? As always, if you have questions as we go through here today, or if you have ideas or comments, feel free to holler. And know that in R, there are many ways to do the same thing. Oftentimes that annoys people because people want to know, how do I do this? I don't want to do it like 5 different ways. I'm going to show you how I'll do it. And oftentimes, if you've watched these live streams, you know that people will chime in with ideas, and I will try that. That happened last time when someone talked about using a named vector as an argument to some of the scale functions, which I had never seen before or thought of, and I tried it. I was like, this is amazing. This is so cool. I'm going to start doing that. And I did that. So, and we'll do that again today. So by all means, feel free to use the chat to ask questions or make comments. That's one of the reasons that I do these live, is so that you can participate. Not quite to the point where we can have live participation with audio and visual, but having this text-based chat is the next best thing. Okay, great to have you, Code with Biologist. Wonderful. So let's go ahead, and again, we're going to look at panels B through E and trying to recreate those. To focus in on those panels, I've made panels B through E, only looking at those panels, and I have that here. And so let's head over to our studio, and I have here the invader displacement.r script that I created in the last episode, and if you recall, that is this code here, okay? And so this is where I'm starting from, is this code. Again, if you didn't watch last time, don't worry, but do go back and try to watch that when you have a chance, okay? And so again, as you can see here on line 17, I have started the panel FG data as well as all of that other code, okay? So I'm gonna come in here, where were you? Right here. And I'm going to put in a bunch of spaces, line breaks, because I want to do panels B through E, not through G, right? And so we'll focus on B through E and then see if we can't tack all that together. I'm going to start largely at the same place where we're going to use the tidyverse to get us things like ggplot2, dplyr, the pipe, string R, all sorts of packages like that. Read Excel will allow us to read in the Microsoft Excel workbook that goes with this figure. ggtext allows us to do cool things like superscripts and subscripts, embedding HTML, which we'll figure prominently today. We'll use the glue function that allows us to more easily paste together text. Show text will allow us to bring in this Nunito font. One of the things that stood out to me about this plot also is that the font is a little bit different. Also, this plot, I should say, the originals, they tell us were made in GraphPad Prism, not in R. So that's pretty cool. And then patchwork, which we used last time, but we'll use again to compose the different panels together into a single figure. One other thing, I commented on the things I would change about this figure. One other thing, as I go through those, that stood out to me that I really liked about this was that they have these cartoons. I'm calling them cartoons, icons, whatever you want to call them, that describe the experiment that the data represent. Okay, so again, just to refresh ourselves, in this experiment, they start with a culture tube containing the bacteria indicated by these blue, right? And so you can kind of, again, down here, see in the legend, the resident, right? And so this is resident, it's a wild type E. coli. And then they, after a few hours, 8 hours, they inoculate in a invader. And so they're looking for the conditions where the invader can overtake the resident population, okay? And so in this panel B, again, it's a red open, so we see here, right? And so that's the wild type. So basically you're taking a wild type invader of E. coli, trying to colonize a wild type resident and see if they would, one would supplant the other, okay? And so as you can see in panel B, they don't. And so that's what this cartoon is showing, all right? The cartoon in B, again, has the same type of setup, but we notice the gray fill on the resident indicating that it is a mutant that can't utilize sorbitol, right? And so the invader has a nutrient, sorbitol, that the resident can't use, okay? And so that's what's being indicated here with these two circles or this Venn diagram looking thing, okay? And then in panel D, we have, again, metabolic overlap. So similar to up here, so they're both wild type in that they, in this case, both can use sorbitol, but the invader is producing a toxin. And so they're producing a collicin. And what we can see is that that doesn't impact colonization. And then over here, we can see in panel E that the invader is producing a toxin as well as can utilize sorbitol, whereas the resident cannot, right? And so we can see in this case that the invader can colonize and drive out the resident, no doubt because of the toxin, whereas when there were no toxins, but only having that non-overlap of the nutrients, the invader was able to co-colonize with the resident population. So again, I think these cartoons do a pretty nice job of describing what's going on in the panel. The one thing I would like to change in this, again, thinking about kind of space management, would be I'd like to have the cartoon and this title to be on kind of the same horizontal plane, right? And perhaps put the cartoon on the left and the title for the panel on the right, so that it's more clear that that title is describing what's happening in the cartoon. Okay, so we'll do that. And so I went ahead and in my directory here, I I created 4 PNG files for those 4 cartoons. Okay, and so you can see I've got these here. I did subtract out the white background, and I think there'll be advantages of that, but I've basically done the part of creating those cartoons separately. I'm sure you could make these in R. I know you can make these in R, I will say, but that's not what I want to do in this episode. So I would imagine that you could make these using Illustrator or R or the dreaded BioRender. It always breaks my heart when I look at Figure Legends and see that, well, like, you know, this was made in BioRender. It's like, oh, you paid so much for that, and you still have to say that you made it in BioRender. Anyway, that's for another day. So, like I said, we're going to use these cartoons and embed them in each of the panels. Okay, so let's go ahead and get started. And maybe where I will start is with panel, well, the last episode I did like panel F and then added in G. Maybe what I'll do here is let's start by doing all 4 at once and see how that strategy works. When I did like panel F and then brought in G, I had to kind of generalize the function after the fact, right? And so I'm trying to do this in a dry way so they don't have 4 big code chunks for each of these 4 panels. I'd rather have one big code chunk that gets called 4 times, okay? And so that's the strategy I'm going to try to use today, all right? So again, if you have questions along the way, holler. I'm, again, using R here in RStudio, version 4.5.2. So before I forget, we'll go ahead and load all of these functions, get these all loaded up. The Nudito font probably isn't the identical font that they use, but it's pretty close. And there's a lot of great free fonts that you can get from Google Fonts, and that's what this function is allowing us to do here. I then also have the Excel workbook, and let me open that because we will need that for our work here. And that's this figure 2 data XLSX. And you can see this is the workbook. And on a previous episode, someone said, please don't make your data available as Excel workbooks. And I fully agree with that. This is how Nature makes it accessible, right? So Nature tells their authors to make their data accessible through Excel workbooks. In other episodes, we've seen like each panel of one figure be a different tab in that workbook. In this case, it's a different section of the same page, right? So they've got panels B, C, D, E, and F, and G, right? And so we talked about F and G in the last episode. And so now we're going to be talking about B through E, okay? So again, I would prefer these to be TSVs or perhaps be a single TSV all joined together. The data that we had here in F and G are really like the last column or the last row, I guess, of these 4 other panels, okay? So F and G here is a little bit redundant from what we have up above, but that's fine. So let's go ahead and start thinking about how we're going to read in panel B. And again, the XLS file is that, and we can then, we've got it downloaded as we already saw, so we could do read XL, and I thought I had done this, but maybe not. So, right. So I do read Excel down here for panel FG, but because I'm going for a different section of that workbook in each read, I have to call read Excel multiple times. So for this one figure, I'll be calling it a total of 6 times, but for panels B through E, we'll do it 4 times. So we'll do read Excel, and then the file we want is XLSX file, and we then want to use the range argument. And again, for panel B, let's start there. It starts at A4 and goes through S8. So we'll do A4 colon S8. So, and I think I should do read XL. So the package is read XL and the function is read Excel. All right, and I probably forgot to load this. We already downloaded it. There we go. Okay, so now what we have is the hours, and then we see the resident strain, and then columns 3, 4, 5, 6, 7, 8, and then that we see down here that there's 10 more variables, so it goes out to column 19. So again, if we come back here, we can see that they are doing funny things with their column headings, right? And so so this is going to vary for each of the 4 panels. So this is going to take a little bit of work to get it to work right. So, and eventually what we'll want to do is we'll want to gather the columns together. So the column names themselves don't really matter, but they're different replicates, and what they represent is important, right? Like we have like the resident versus the invading. So let's come back here, and I think what I'll do instead, or to add to this then, will be call names. And we'll do, what will we do? We will do C, and then I'll do hours. Maybe I'll make this time, just because, keep it there. And then we can see that, again, we have 9 columns for 1 through 9, 1 through 9, okay? And so then we'll do 1 colon 18. And what does that get us? So that gets us those column names to be numbers. And then I also see that because I added that column name, now what it's doing is it's creating that row 4 to be its own row. So if I do A5 S8, we get rid of that, okay? So maybe we can do this a little bit nicer. So let's go ahead and do what? We can do glue, and I will do resident underscore and then 1 colon 18 in curly braces. And actually I'm going to do 1 colon 9 because there's only 9. And then we'll repeat this type of syntax for the invader. All right, and so we'll clean up our commas here, and I think I misplaced a parenthesis there. Okay, so the nice thing about RStudio, of course, is it shows you kind of with this highlighting where your parentheses should be. So let's go ahead and run that. And so now what we see is that we've got time, resident 1 through 6, and then down here we have invader 1 through 9. Okay, and let's go ahead and put this on separate lines so that things don't start scrolling off the right side of the screen. And so now we'll want to do pivot longer, and we'll do what? We will do minus time, and let's do, let's do that. Well, let's do names to, and we'll do condition rep, and then values to equals density, right? And so now we have a tidy data frame where we've got time on the first column, the condition and the rep there, and then the density. And so I'm trying to think ahead about how I want to bring in the other panels and how much of this then is going to be redundant, right? So this is going to be unique to that panel B, but this probably isn't unique, right? So let's go ahead and hold off on this for now, but this is helpful for getting us to think about where we're gonna go, right? And so we could also then do something like separate, and that's the old function, and I'm forgetting what it's called now, but it'll tell me. So we could do like separate condition rep, and then we'll say into, and we'll say condition and rep, right? And then we'll do sep equals underscore. And so then that we can see separates the condition and the rep. Actually, it didn't complain, but let's figure out what that new function is. I remember seeing that the separate has been superseded by separate wider delim. So clearly separate works, but let's do separate wider delim, and let me get the syntax here, right? So the column is condition rep, the into, oh no, that's separate. I want condition, I want this other one. All right. And so we see the data, the calls, so this will be the column, and then the delim is this. So maybe let's put these into different order. So this is delim, and then the names are just going to be this, right? And so this then takes me off the right side of the screen. So we'll go ahead and run that. That works perfectly, no problems, and we're in good shape. And yeah, so, but again, this syntax, these lines are going to be applied to all 4 of the panels. So let's go ahead and for now, comment this out, and we'll save that for next, right? So now let's think about how we would read in panel C. So again, I'm gonna copy this down, and I need the range for panel C. So panel C, again, we're gonna give it the header, and so we're gonna wanna read in from A14 to Q17, A14 to Q17. Remember that for me, okay? Because I'll forget. A14, Q17. So A14, Q17, and let's see. Yeah, okay. And so that's 8 and 8, right? And so then what we can do down here would be resident 1 to 8, invader 1 to 8. And we've got the resident and the invader, but we also want to think about like the other components of that, right? Like, so like there's a wild type, there's a mutant, there's going to be the toxin produced, right? So let's maybe go ahead and bake that in as well, right? So resident, wild type, no tox, something like that. And then by building these names like this, we can, again, use our separate. We can modify that later to build out those columns, right? Because we can imagine if we come back to the figure, right? Like the resident, we're going to color, the resident versus the invader, we're going to color differently. The wild type versus the mutant, we're going to give a different fill, right? Whether it's white or gray. And then black versus white for the toxin, right? And so maybe we don't want the mutant and the toxin to be separate columns, right? So maybe here we'll do one thing, wild type, no tox, or maybe I'll do what? Yeah, that'll work. Wild type, no tox. And then we have in C, we have, oh, let's come back to this sheet. So here we have the mutant, right? So the invader in B is the wild type, no tox. And then here we have, I'll say KO for mutant with no tox. Okay. And yeah, so now when we read this in, we get, again, our columns properly named. And so now we can repeat this. So go ahead and copy this down. Now we want to get the range for panel D. And again, that's going to be A23 to K26. A23 to K26. And then this is the resident wild type and then the toxin producer. So we'll then do, so the resident, what did I say? is wild type. So wild type, I guess wild type is non-toxin. So let's go ahead and take out that no tox for these other ones. Again, as we go through this, we get ideas for kind of what will make our work easier, right? So we're gonna have wild type, we're gonna have the knockout, we're gonna have the toxin, and we're gonna have the wild type knockout and toxin. So maybe here, to, again, make it simpler, I'll do KO. Okay. So then here we have the wild type and we have the toxin. Okay. And so here we'll say tox. And so this isn't 8. I believe it's 5, right? 1, 2, 3, 4, 5, 5 and 5, 5 and 5. All right. So now we've got our resident, all that. And I'm realizing I've dropped out an underscore. So we want that underscore here. All right. So hopefully you can see the difference in approach here, trying to do all 4 panels at once versus do one panel and then bring the others in. We'll have to see at the end which we like better, but I kind of like this iterative approach where I can kind of begin to generalize things a little bit more. All right, now for panel E, it's also got 5 and 5, and it's going to start in A32 and go to K35. So A32, K35, and it's 5 and 5. And this is the KO as the resident. And the invader is what? E2, right? So that's the tox, okay? So the resident is the knockout and the invader is the tox. And that looks right. Cool. And let's see if I missed anything. So the resident KO, invader wild type, resident KO, invader tox. Okay, so if we run this, that all looks good. All right. So again, as I go through this, feel free to holler if you've got questions or if you don't understand what I'm doing here. And now what we can do is to begin to pull these together. So we want to make a single data frame with all of these together. And so to do that, I'm going to use bind rows, and I'll do panel A equals, well, let's put this on a separate line. And we'll have to do some cleaning up here. And I know there's a way to reflow my code, but we'll get there in a second. So then we'll get that. And then this is going to be panel B equaling this. We need a comma here. Panel C equaling this, comma there. And then here we'll have, it's not panel A, it's panel B, C, D, E. Because panel A is the overall model describing the experiment. All right, so now we need to add a argument called .id, and I'll then call this panel. And because it's weird, I don't know, maybe it's not, but weird to have a column name with the variable name in that column. Let's make these B, C, D, and E. Running this now, we now see, oh, that's interesting. We now see that we have something weird. So we have 16 rows and 33 columns. And so what is happening Yeah. What's happening is that we have different columns in B, C, D, and E, right? And so when I do bind rows, it's basically making a new column whenever I didn't have that column previously, if that makes sense, right? And so that's kind of fine, I think. I'm not going to worry about it because ultimately I'm going to feed it into pivot longer, right? And yeah, I'm going to feed it into pivot longer, and I can then remove those NA values. So it's putting in NA values wherever I didn't have that column, right? So like panel C didn't have resident wild type. It had resident KO, right? So, all right, that's fine. It's just a little bit jarring. I didn't expect that result, but I should have because that's how it works. All right, so then we're going to do pivot longer, everything but the time column. And we've got that panel in here. So maybe everything but panel and time. So we'll do C panel time. And the names too are going to go to, let's go ahead and call it condition, genotype, rep, and then the values are going to be the density. Okay, so we'll put these on 3 separate lines so it's easier to see what's going on. Then when we run this, what we see is that we've got the panel, the time, and the condition, and the rep, and then the density. And there's going to be a bunch of NA values in here, right? And so you can see that there's 496 rows and 4 columns. So if after this, I go ahead and do drop NA, now we see that we've got 216 rows. So we removed all those NA values and we're in good shape. And so now what we want to do is go ahead and separate wider, delim, right? So we've got the condition, genotype, rep, and we also want to specify the name that it's going into. So let's clean that up. So we've got the condition, we've got the genotype, and the rep. So running that, we now see panel, time, condition, genotype, rep, density. Cool. All right. And I realize you haven't seen my beautiful face. Wow, someone from Azerbaijan. Welcome, Tamaz. So finding it hard to access data in your visualization, especially when I have to scrape. So the data in the data visualization, let me show you where I got that from. Let's see, open that up and open this in Google Chrome. So this is the web link for that. And if you go to figures and then figure 2, full-size image, you will then see down here source data. So clicking in that source data, if I hover over it, will then bring us to source data figure 2 here. And then we see in the bottom left corner that that's an Excel workbook. Okay. And so I will go ahead and copy the link address and plop that here in the chat. And so that is where you can get the Excel workbook. I do my best to pick figures from journals that are open access, or at least the articles are open access, and that make the data accessible as I just showed. Okay, so hopefully that works, Tamaz, and thanks for joining us from Azerbaijan. That's awesome. I never cease to be amazed by the reach that these videos have. So sitting in a little town outside in southeastern Michigan that has about maybe 10,000 people. So it's not a little town, but it's small, right? And so they have this global reach. It's very amazing to me. It's very humbling. All right. So we've got our data. We've got our data frame that's got all of the data that is contained in this plot, right? So now I'm going to go ahead and focus on panel B to get started. So we'll do filter panel equals B. And so that gets us 72 rows of data. And we'll go ahead then and do ggplot AES. On the x-axis, we're going to want time. On the y-axis, we're going to want the density. Our fill is going to be the genotype. And our color is going to be the condition, right? And yeah. So then let's go ahead and I'm going to do geom_point. And yeah, let's start there. So again, geom_point will give us a scatter plot, right? This will get us a plot that looks a lot like what they had. And well, except that the resolution is screwed up. So I'm going to go ahead and save this to file. So we'll do ggsave, and I will call it panels B through E, but not original. And I want to get the width. So the width is 7 inches. That's what it was for F and G. The height, when I look at my printed page and use my kid's ruler, the whole thing is 6 inches, and maybe we'll say that it's like 4 inches for this particular panel. Actually, I can come down to the bottom and see that this is 1.9. So if the whole thing is 6, I can make this 4.1. Oh, back up here. All right, so I'll go ahead and save that to file. And now I will, a bunch of windows open here. Panels B through E. Again, this is panel B. And we can see, yeah, we can see we have some work to do, right? but we're starting, right? So let's, I'm thinking about how I want to do this. And so I said I want to build all 4 figures together. So let's go ahead and do that, right? Maybe before I do all that, let's go ahead and think about how we would, so we're gonna have to build a function to do the plotting, right? So let's see. Let's go ahead and let's add in the other geoms. And I think my idea of doing all 4 panels at once is kind of breaking down here, because I am going to have to make a function to build the figure, okay? So yeah, so I don't think that's gonna work. So let's go ahead and see how far we can get doing this with one, and then we'll bring in the others. And maybe what we can do to test things is to change what we're filtering on, right? So we could do C, right? And so then we get panel C. Okay, so let's, like I said, add the other geoms. So we'll do geom line. And again, this is panel C. And adding geom C, hopefully you see something funky here, right? It is connecting all of the points in the data, right? So that's not really what I want. What I want, if we go back to the original, is that the line is going through, believe the median. Let's go down to figure 2 and see if we can say, let's see, it probably says down here, no, oh. Okay, lots of information here. All right, CDE. Let's see, population. Black lines represent the median. So I'm going to assume that the medians are used all throughout. Okay, so we saw this in the last episode when we drew these black lines, but we can draw the lines using stat summary. Okay, so we can do stat summary. We'll do geom equals line. And so that's going to draw a line through our summarized data, right? And so to do that, then we need to do fun and we'll do median. So this will calculate the median for each time point, and for each condition, right? And so we will then get a line that goes through the median like we saw in the original, okay? Or this, we should. And there we go. We now have a line going through all of the jittered, or all of the points for each of the conditions, right? Cool. All right. Now what we want, thanks, Code with Biologist. Yep. Now let's go ahead and modify the axes. So in the original, they have log on the y and continuous on the x. And so we'll go ahead and here and then do scale y log 10 and then scale x continuous. And I'm going to do limits C0 to 72. And so now what we get is our log scale on the y-axis and our continuous scale on the x-axis. And let me kind of shrink these down so I can fit them on the same page, like so, right? And again, this space is going to get subdivided for the 4 different plots, but we'll work with it for now. And so, again, in theirs, it went 8, 24, 48, 72 on even intervals. And so you can see 8 is here. And so if I wanted to get the effect that they had, which I don't want, what you could do on X would be like as.character around time. And oh, it's upset because of my scale. So let me go ahead and turn the scale off for now. Let's see, and try group equals 1. Okay. So now what we get, as you can see, and this seems to have done some funky stuff. Yeah, this is doing funky stuff to my stat summary. So again, we're not going to stick with that. But here you can see that we have even spacing of those 4 time points. Also, because I treat it as a character, it's putting it in alphabetical order, not numerical order, because the 2 becomes before the 4 before the 7, and the 7 before the 8, right? So, all right, so we'll put it back. But I think they effectively treated their time data as categorical rather than as continuous. So let's go ahead and put that back. And there we go. Cool. So something weird that's going on here. That is weird. Is that my line for the resident is coming back on itself. So let's go to panel B and see what we get. And it's connecting those 2. I think what's happening, oh, that's because I have group equals 1, right? Okay, so I want to turn off that group equals 1. That's something that I did to get it to work. So we'll turn that off. So when we do group equals 1, that's basically telling geomeline to treat all the data as one group and to basically connect all of the lines together, which is why we had that line going across between the 2 conditions. Okay, cool. All right, so again, we now have the y log scale, and we have at least my version of what I'm going to roll with for the x-axis. And so you can see, hopefully, that the points look pretty similar to what they had. I'm going to quickly modify the y-axis. So down here in panel FG, let's see. I used chord Cartesian probably to set the limits, did I? Maybe not. Oh, chord Cartesian right here. Okay. So I'm going to put my y limit into back up here for this other plot. So I'll put the limits in here. This needs to be chord Cartesian. And so we'll do y lim equals that. And I'm going to do x lim equals c0 to 72. The difference between doing it in the scale versus chord Cartesian is that if you do it within the scale function, before it plots the data, it removes any data outside of that range. And so a benefit of putting it within chord Cartesian is that it leaves the data there even though it's outside of the range, right? And so that's going to be helpful down the road for kind of plotting our titles and our cartoon. I'm gonna probably plot that using something like geom text or geom rich text. Okay, and so I see theirs actually goes up to 10 to the 10, and so maybe I'll have mine go up to 10 to the 10, and we'll probably adjust that before too long. And so now we can see that we have kind of the same limits that they have. Mine goes down to 10 to the 1 because I liked having more space below their limit of detection. Okay, so let's go ahead and make that subtle modification that I wanted to make to the points. So they've got the points all on top of each other. And, you know, if I got the fill correct and the color right for the border, you'd have better resolution. But again, it's still going to look like what they have up in the original. And so what I'm going to do, instead of geom point, is geom jitter. And so geom jitter adds a bit of noise to the x-axis position to get that separation of the data. Okay, and so you can see we've got that separation, right? And so we can play with the separation a bit to get it to look a bit better, right? So let's go ahead, back up here. And so geom jitter, I'm going to put in here position equals position jitter, and I'll do width equals, and so I think it's going to be, the width is going to be the units in terms of hours. And so let's go ahead and put in 2. So it'll be plus or minus 2 hours. I'm also going to set the seed so that we get a consistent result every time we run it. So I'll do 1976, 0620, the best set seed ever. Oh, and it's, what? Probably just supposed to be seed. There we go. All right, there we go. So now you can see that with like plus or minus 2 hours, we get a good amount of jitter without being so wide that it runs into the other time points, right? And so I think this looks better than what we had previously with them all stacked up on top of each other, because now I can see better, at least, how many points there are. Okay, so cool. All right, now let's go ahead and modify our points. And so I said in like one of the previous videos that it's almost like they watch my videos to know what type of plots I like or what aesthetics I like, because they use my favorite plotting symbol, which is shape 21. And so shape 21 is a circle where you can change the fill color of the circle to be different than the border of the circle. And so now what we see is that we have what? So we're getting the fill is that salmon, or that orangish reddish color, the salmon color. So we can see that they're all salmon, right? And then the border is a different color and the line is a different color, right? And I don't know that I want, so I'm also thinking ahead towards this legend and how we're going to change it. I don't know that I want the line through that legend, but maybe we can worry about that later. Let's go ahead and try to customize the colors, okay? So where were we? So I'll do that back up here. I'll do scale, color, manual. And this was, again, where last time someone made the suggestion of using a named vector. So I'll do that. So C, and we have, so for the color, we have resident and we have invader. And so for resident, that was the bluish color. So I'm going to come back down here and see if I can't find that blue color. And so I'll copy these and bring them back up. All right. And so again, the resident is the blue, the invader is the red, and all right, and then let's see, it's not happy with what I did. Why aren't you happy? So this should be values. There we go. And so now you can see that we have the red line for the invader, the blue line for the resident. The border on those circles is blue and red. And so now we need to change the fill color, right? So let's go ahead and do that again. We'll do scale, fill, manual. And I will do values equals C. And we're going to have a variety of values here, right? We're going to have wild type, we're going to have the knockout, and we're going to have the toxin. So we're going to have those three different colors. And so wild type, I know, is going to be white. So the hexadecimal for white is FF. So maybe we can do everything in hexadecimal. The KO is going to be a gray color. So let's come back down here and see if I can't find that. Yeah, and so maybe I'll go ahead and copy those and bring it back up here to the top. So we got the white. The call E2 is black, so that's the toxin. And the hexadecimal for black is 6 zeros, okay? And then KO is going to be this SRL, and that's going to be gray, which is probably like, that's too dark. So gray is going to be like the same number repeated. So if I do, that looks about right. So let's roll with that. And then we'll add that in. And so now what we can see is that we've got our points with white fill and our lines, right? Let's see, a couple questions. Yes, so Mike says, as an aside, you can use geom_point if you then use position jitter. That's exactly right. If I come back up here, I can show that that the default position for geom_point is identity. And so we get the same thing. And I don't know, I prefer, oh, what did I do wrong? Okay, I prefer to say geom_jitter. I don't know why. I think I don't always do this type of stuff. It would be nice if there was a seed argument in geom_jitter so that I wouldn't have to call position jitter. The only reason I'm calling position jitter here is to set the seed, because I can set the width outside of the function, right? So I don't know. These are little things that you tolerate. Let's see. Why not use the alpha, Brian asks, to increase the transparency of the points instead of the horizontal jitter? The jitter might be a bit misleading to a reader that the measurements are taken at different times. That is a trade-off, I would say, right? So what he's asking is like, why not set the alpha? And I don't know that the reader is going to see, even with alpha, that there's 9 points here, right? Because again, that's right here. And I don't know, I feel, yeah, I think that's a trade-off, and that's like a decision you have to make of what is more or less deceiving, or what is more clear, or what is more obtuse. And so I think that's a trade-off, right? For me, I would prefer to do the jitter, because I think it's going to be clear that there's 4 time points. One other thing that I commented on in the critique video was that in panel A, they lay out the model, right? And so one thing that would be helpful to that point, I think, would be to draw some type of mark at the sampling points, right? So maybe the arrows could be, maybe they could just put like, I don't know, some color X or some color arrow for the 4 time points where they grabbed samples from. And then that way it would be more clear that even though you see the spatial jitter on the x-axis. That doesn't mean that we were kind of sloppy in what time point we took samples from. I don't know. These are different things that you can do. Lots of great comments here. And Mike said, in this situation, I would put height equals 0 to be absolutely sure it's only jittering the x direction, right? Yes. So that is a good point. And so width equals 2, height equals 0. And sometimes I do this when I'm pivoting the table 90 or pivoting the figure 90 degrees because I get confused of what is it considering width and height. So if we do that, though, you can see nothing changes. So by default, the width varies, but the height is 0. And again, when I pivot the axes 90 degrees, I always get confused what's being changed. But yeah, here, nothing thankfully changed. So yeah, and Brian, like to your point again, like there, as much as I might talk about like a critique or how I would do things, there is no perfect plot, right? We'll get to the end of this and there'll be things like, I wonder if we could have done this differently, right? So there's lots of trade-offs. All right. So one thing I'm seeing is that my genotype only shows up as wild type because that is what we have in the data. We don't have the knockout or the toxin. And so I'm wondering if there's a way to get it to show those other values. So if I do scale, fill, manual, looking at these values, at these functions. So let's scroll down a little bit and see what it says. So drop. Should unused factor levels be omitted from the scale? The default is true. So it uses the levels that appear in the data. False includes the levels in the factor. So I think what that means is that we could come in here, we could do drop equals false, but I don't think that's going to work because the text over here says factor levels. So I'm not sure if it's considering my column where I'm getting these values to be a factor or not. Probably not. And so we can see that we still have genotype. Okay. So what that means is that we need to make the column that we're using for fill genotype to be a factor. Okay. And maybe what we could do is go ahead and do a mutate on genotype to be a factor. And we'll do factor on genotype. And we'll do levels. And I'll do wild type, KO, and toxin. And so let's see if that works. I think it will. There we go. We now have wild type, KO, and toxin. And it's dropping the symbol though, which is weird. Let me see if it says anything else in here. Yeah, I'm not seeing anything. I'm going to leave that in there for now because if we use patchwork to bring this all together, then I think it will show up and it'll be fine. So again, what I'm commenting on is that we lost the genotype information here, the dots, right? And what ultimately I'd like to do is basically have these overlap with each other to some degree. And actually, as I think about it, oh, bother. Maybe I want that now, right? That we've got really these 4 conditions. And I went through all that rigmarole to make the 2 different combinations. And so maybe, yeah, because I want one legend. I don't want 2 separate legends, right? So let me go back to that. Okay, so that's back up here where we did all this. We had like the resident wild type, and let's see. One thing I could do is change the delimiter between like invader and wild type, resident KO, invader wild type. Yeah, so this, I'll go ahead and do like that. All right, and then we're going to go ahead and do condition rep. So this is what we had initially, right? And so let me see what this looks like. So now we can see that we have the condition rep. And then we'll do the separate wider delim. And then this is condition rep. The delimiter is the underscore. And then I'll leave it as condition and rep, which again is what we had way back when. And so now let me go ahead and comment out that mutate line. And so my fill, I'm going to make condition, my color condition. Yeah. So let's try this. Nope, it was unhappy. Let's see. It's upset with my manual. So let's go ahead and remove that. Oh, because these are wrong. Okay, let's go ahead and comment these out. There we go. Okay, so we're back there. So we have invader wild type, resident wild type. So coming back here now, we're going to have resident wild type. I think that hyphen is going to cause me headaches. So I'm going to go ahead and instead of using that hyphen, I'm just going to, I'm going to use an underscore there. All right. Sorry. I kind of went back on myself. And then instead of this hyphen, instead of this underscore, I'll use a hyphen. Because if I use that hyphen in a name, R is going to think that's a minus sign, right? So we have to be kind of careful about the symbols we use. But in this case, it'll work because we'll get rid of that hyphen pretty quickly. And condition wrap, pivot longer, and then our delim will be a hyphen, right? So now when I run this, again, it's still upset about my scales. Go ahead and get rid of that. And within the separating function, there's probably a way to make a more sophisticated regular expression, but I don't really care to mess with that. So anyway, okay. So now we've got this. So we'll do resident underscore wild type, and then invader underscore wild type is that. But we're going to have 4 values, right? So we're going to have the resident KO is going to be the same color, and the invader toxin is going to be the same red. Okay, up. And I'm doing this because I want to have at the end a single legend. I don't want separate legend for the fill and a separate legend for the color. I want it to be together. Does that make sense? And so then our fill, we're going to have, again, the same 4 values, but different colors, right? So the wild type is going to be white and white. And the KO is going to be the gray, and the toxin is going to be black. We'll get rid of that. And I need a closing parenthesis here. So this should work. Famous last words, eh? And so there we go. We now have a common legend for our fill and our color. And now if I come back, I should be able to do like drop equals false. And maybe I'll put this on a separate line. And I'll do the same thing down here for my fill. And of course, nothing changed because I need to come back and make this a factor. So we'll make condition a factor. And then let's set the levels. So why don't I grab those here? Where'd I put you? Okay, right here. And so we have resident, and I don't care about the colors again. And so I'm going to want to do resident wild type, invader wild type, resident KO, invader toxin. I think that's a good order. And we'll put these in quotes because those are the levels. Get that in quotes. And then I think we've got the right number of parentheses. And there we go. Okay. So we've got the space for the other conditions, but we'll get there eventually. All right. So one thing that occurs to me with the line is that our line is going over the top of the points, whereas theirs went behind it. So let's go ahead and to do that, we could put the stat summary before the geom jitter, right? And so now we see their line is behind the points. I'm going to go ahead and turn off the legend there. So within that stat summary, we can do show.legend equals false. And so now we can see in our legend, we no longer have the line, okay? Cool. Let's now think about what? Well, let's think about how we can, what do we want to do next? Let's think about that. So what do we want to do next? So our labels need help. We still need to get in the text at the top. Our legend is going to need some formatting. Let's go ahead and work on the legend since we've already been here. And so within scale fill manual, I can do labels. And I wonder if labels I can do kind of like we did before, right? And so we did values as a named vector. And then where's labels? Let's see, labels. So I wonder if I can give it a named vector. Let's try that. So I'm going to go ahead and copy this. And before I invest a lot of time in doing this, I'm going to just be silly. Or maybe I'll, whatever. I just want to see if this works. And it does. Okay. So again, I can use that named vector to get the right syntax. And one thing I'll point out here is that we're getting separate legends again because the values and the labels between the two legends are different. So if I make them the same, they'll come back together. Okay. So for a condition, so resident wild type, I want to see how they wrote it. So that's resident and then wild type. So we'll do resident wild type. And then the invader wild type was the same type of thing, right? Invader wild type. And then resident. And then they had the delta. So that's like ampersand delta. And then it's going to be italics. So we're going to be using element markdown. So we'll do SRL AEB. All right. And then our invader toxin will be invader. And we'll do WT with Collison E2. And I don't think there's anything special there. Okay. So if I go ahead and copy this down to scale fill manual, then we should have one legend again with those labels. And there we go. Cool. And so now what we see is that we've got the markdown, the HTML for resident that hasn't been rendered. And we've also lost the parentheses after a Collison E2 right there. Okay. So to get that to render, we'll go in and I'm going to go ahead and do theme classic because this is a very, theme classic I think is a good place to start with these. It has solid axis lines, no background, looks good. And let's go ahead then and add to that theme. And we'll do legend.text equals, and I will do element markdown. While I'm here, I'll also do text equals element text, and we'll do family equals Nunito. And so that's going to get the Nunito font family used in all parts of this, okay? And so now we can see we changed the font and we have the rendering of the HTML, but for some reason, so again, we have two legends. So why do we have two legends? Well, because I put the parentheses at the end of colon E2 for a condition for the fill, but not for the color. So let's come back up and fix that right here, okay? So added that back in, we're back to one happy legend. We can also get rid of the name of the legend within these scales. We could do that in theme. We could also do name equals null, and then plop that down here as well. And so now we've gotten rid of the name of the legend. Okay, cool. So the legend's looking good. And it'll look better when we have all four panels together, I think. I really hope. Otherwise, I'm not sure what we'll do. All right, so let's think about the time. And so we want to label the actual time points. So we'll come back up to scale X continuous and do breaks equals C 8, 24, 48, 72. And so we've got those 4 time points looking good. I'm going to set the title here using the labs function. So let's go ahead and do that. We'll do labs, and I'll do X equals time in hours. I'm not going to do time points. I think that's odd. And I forgot to add the plus sign here. There we go. We've got time in hour. Nice. Now let's turn to the y-axis. And so here, we're going to need some markdown. So we'll do breaks. And I'm going to do, 10 to the, and we'll do every 100. So we'll do seek 1, 9 by 2s. And so now you can see we go 10, 1,000, and so forth, right? And so, but we don't want those labels. We want the nice 10 with the superscript. And so we can do that with labels. And here, labels. And here I'll do glue. And I'll do 10, and then soup. So Markdown has, if you use like the caret character, sometimes that works for superscript. It doesn't always work. And also like the tilde sometimes works for subscript, but it doesn't always work. So I have found that it's really just easier to use the HTML tags. So we'll do that. And so then in here, I'll embed this sequence. And I forgot a comma again, did I? Or, oh, I forgot to wrap this in quotes. Gotta be in quotes. All right. There we go, no error. And so now we see the HTML, and we want that rendered correctly. So we'll do axis.y dot text equals element markdown. And I think I got ahead of myself. It should be axis text y element markdown. There we go. And so now you can see we have the 10 raised to the power. Okay. Cool, eh? Let's go ahead and take on the title, which is, they had a CFU per mil. I want to add in what it's actually measuring. So we'll do y equals density, and then I'll do CFU ml, and then soup -1 soup for superscript, right? And then I'm wondering if I actually need the .y. Well, no, I need axis title.y, right? All right. All sorts of ideas come to my head, and not all of them are correct. So anyway, so now what we see is that we've got that density CFU per mil off on the y-axis. That's great. Nice. All right. Let's go ahead and while we're here, and we'll go ahead and put the limit of detection in at 200. And so I'm going to do that. I think I want to do that first because if there's data down there, I want the line to be behind any of the data, right? So I'll do geom h line for a horizontal line, and I'll do y-intercept equals 200. My color I'm going to make gray. My line width will be 0.2. Actually, you know what? I call geom h line down below. I find the find function in RStudio is a little bit kludgy sometimes. Okay. Yeah, so I think I got the right conditions. All right. Yeah, so here. And we need a plus at the end. So it is a 0.2 and color gray. And so now you can see we've got that gray line for our limit of detection down here at the bottom. They have a black dashed line that I almost feel like is thick. It is actually, I think, thicker than their axis lines. And I don't really want to draw attention to that line. I want people to know it's there, but I don't want them to like really stress out about it or worry about it. So anyway, we'll roll with that. And all right. So now let's turn to the text at the top. And yeah. All right. So to place that, we're going to need, I think, a separate tibble. Okay. And so I'm going to call this panel title. And we'll call that, I'll make it a tribble. And we'll then do panel. We'll do panel. And then we'll do what? We'll do the cartoon. I'm going to hold off on cartoon. We'll then do the text. Okay. So the panel and panel A, and again, that needs to be in quotes. The text is going to be this: metabolic overlap, no toxins. And they have a line break in there. I'm going to use the BR tag because I'm going to use geom rich text, which allows me again to use HTML. And so that's what I want to use. All right. And so then in B, we'll go ahead and grab this, copying and pasting that down. And then C will be like so. And then D will be that. Oh. All right. So for now, I'm going to hold off on assigning this to panel tribble. Let's see what it looks like. Okay. So I'm going to add a cartoon column. And this is going to be, well, what do I call them? Over here in my files, I call them cartoon underscore. So here I'll do glue cartoon underscore panel dot png. And so now you can see I've got those names, right? And yeah, so all right, so let's now bring that into panel tribble or panel title. And so now what we want to do is we want to take panel title and we're going to add that, let's see, after geom jitter, I'm going to do geom rich text. And we're going to have to play with the positioning a bit, but here I'm going to use data equals panel title, AES. For the X position, I kind of want it centered. Let me think. Well, while I'm looking at like the centering position stuff, I'm thinking I might want to specify more precisely the limits on my axes. and turn off the expansion. Because I look at theirs, like in the lower corner here, that their tick marks on the y-axis start at the bottom, okay? So I can do that so I'm gonna comment this out for now. Come down to chord Cartesian. I'll do expand equals false, and I'm gonna do clip equals off. So clip equals off will allow me to plot stuff outside of the plotting window, right? So you can see like this cartoon is outside of the plotting window, and I'm gonna need to make room and plot it up there. So clip equals off will allow me to do that. And I do, though, want some room to the right of my 72. So maybe I'll make that 76. Let's see what this looks like. All right, that didn't work. What did I do wrong? Oh, I changed the wrong thing. So that should be 72. This should be 76. All right. There we go. So that gets us the 10 to the 1 at the bottom here, gets us some room. And so one of the reasons to do that then is that I know what the middle is more easily, right? So my limits are 0 to 76. That means that the x position in the middle is going to be 38, right? So we'll do, what did I do? We'll do x equals 38, and then y, this is 10 to the 10. So maybe I want to go to 10 to the 11, 1e to the 11. And then my label is going to be from panel title. What did I call that even? Text. All right, text. And I want my HJust for my text to be left justified. Okay, so we'll go ahead and try that. I'm pretty sure this is not going to work as desired, but hey, we'll give it a shot. And I see some message, problem condition not found. Oh, and that's because with geom rich text, I'm bringing in my own data panel and I'm using my own aesthetics. So I want to go ahead and do inherit.aes equals false. And so we don't see it because there's no room up the top to see it. So to make room to see it, I'm going to go ahead and do plot.margin equals margin. And at the top, let's do like 20. And the R, I'm going to do like 3, bottom 3, L3. If I don't set those other 3 sides, it's going to turn it to 0. So we can see the label there, right? So let's get some more room. So let's take that up to 30. We can see it. And we could probably bring it down a bit. Let's see. I set that in geom rich text. Let's do like 5e to the 10. Okay. And so that's like this position here, right? So let's go ahead and bring it down a little bit more. Let's do like 3e to the 10. And I think I'm going to need more margin at the top, but let's see. Let's go ahead and remove all that ornamentation from geom rich text. And we also want to bring in our font. So let's go ahead and do family equals Nunito. Again, if you're bringing in a separate font family, you can change it in theme, but it will only apply to the theme elements. And if you want it to apply to things like geom text, geom rich text, geom label, those types of things, you have to set that within the geom because it's an aesthetic itself. And so we're going to use the family there. And we want fill to be NA, and we want the border color to be NA, and we want border padding. I'll do unit 0 PT. I think I got those arguments right, but I might be wrong. Yep, it's upset. Ignoring unknown parameters, border color. Maybe it's the other way around. So I think maybe it's padding border and padding color. Nope, I don't know what I'm doing. Okay, let's do geom rich text. And let's see. Label padding. Oh, what did I do? I did, okay. I did border. Yeah. Label padding, not border padding. All right. So we'll get label.padding, but I also want the label color. And I think that's going to be down here in the aesthetic section for this function. And so that's going to be label color. All right. I thought the border, I don't know, whatever. Label color and give that a whirl. No errors this time. And so now what we see is all four of our labels right smack dab on top of each other, right? So I need to go ahead and, for now, do a filter on this. So we'll do filter, panel table, panel title. I'll do panel equals A. I believe I'm still doing A. Oh, it's B actually. Okay, let's put this back to B. It should be, yeah, it is B, right? Okay. And so now we see the one label. That looks good. Now let's add in the cartoon. So in previous episodes, when we were inserting like watermarks and other things from figures presented in the media, they put in watermarks, they put in pictures, and I've kind of struggled with how to do it. I think I finally found like the easiest way to do it, and it's basically to use ggtext. And so we'll do another geom rich text. So I'm going to go ahead and copy this down. And I'm not going to worry about the family or the hjust. Well, the hjust we're going to make one, so it's going to be right justified. And so what I want would be like the cartoon, right? And so what we see is that we have cartoon PNG. I don't want the file name, I want the actual cartoon. So what we'll do is we'll come back up and let's see. Here I have glue cartoon that. So what I can do is I can put this in an image tag. So we'll do image cartoon. I'll do image src equals this. I think I have to put it in single quotes. Let's see. So this now we'll put in the HTML directing it to the image file. No errors. Whammo, there's my cartoon, but it is huge, right? So we need to add the height. And so we'll do height. And then I think I will do like 20 pt. I think that'll work. We'll see. I don't do a lot of HTML, so this could be wrong. No errors. But something didn't work. I forgot to close out the anchor right there. So just because there's no errors doesn't mean that it's right. Oh no. NA values, something happened. All right, let's come back up and let's see. So I am going to go back to my browser and do HTML image tag. And let's look at the documentation here because, like I said, I don't do this a lot, so I forget. And I think it doesn't want my unit. I think the height by default is in pixels. Okay. So it doesn't want my PT here. We'll try 20. Very good. No warning messages. And so now we see we've got our cartoon. It's a little too small. So instead of 20, let's maybe take that up to 30. And so there we go. Could probably be bigger. Let's go take that up to 40. My sense might change as we move things around, but I think that looks pretty good. All right, so good. So this is panel B. I like how it looks. I'm glad Mike allows this. Mike says, can you explain why you can't just use a normal title? That is something I thought about. And why I'm not using a normal title is because I wanted to have both of these be center justified. And I didn't really want to worry about, because like some of these strings, like invader private nutrient or invader with toxin, are different lengths. I didn't want to worry about like that center point moving in each panel. And so by doing geom rich text right at the middle of the panel, and then using right justification, left justification, or left and right, whatever, I could pin that right at the middle. So that was my logic. I think you definitely could do it with labs, but then you're going to be futzing, I think, a bit with like the horizontal justification on each panel, and it just seemed painful. So I didn't want to worry about that. So hopefully that makes some sense. All right, so I think we've got the plot the way I want it. And so now what I'm going to do is think about, where does the plot start? So basically the plot starts here. The plot starts here. All right, so I'm going to go ahead and pull this down, and I'm going to make this a function. So I'll say plot be function something, and then we'll indent all this over and then close that. And I want to see what I called this down here. So I called it plot panels FG. So maybe I'll do the same thing. And plot panels BE. And then we gave it the plot title. So maybe here I'll say panel, right? And so what I did previously was I took this data frame and then basically treated it like a global variable. So I'm going to call this, well, I'll call it panels BE data. Oh, and I screwed something up. All right. And I think I have like a pipe at the end of this. Yeah. So I'll get rid of that. And I'm also going to get rid of this. So then what we'll do will be panels BE data. I need to load this. And then I'll do filter. Well, I had it already, didn't I? Yeah. Panel equals B. And we saw this before. So I need this to be like P. I need it to be a different, well, do I need it? No. I think panel equals panel will work. Okay. All right. And so then this can pipe into here, right? And then remember, I did a filter down below with geom rich text where panel equals B. Let's do panel equals panel. Too many pop-ups. Panel equals panel. All right, so let's run this. And then we're gonna have panels, plot, sorry, what do I call it? All right. And then we'll do B. So that gets me an error. Unable to open cartoon A. Don't know that I called A. So that must be back up ahead. Oh, I did A, B, C, D rather than B, C, D, E. Someone probably saw that and was yelling, and I couldn't hear you. Sorry. All right. And does it work? It almost works, but not quite. It's putting them all on top of each other. And why are you putting it all on top of each other? So we have panels BE data. All right, so we've got all that. Panel equals panel. I wonder if it doesn't like that I'm using the same thing. So I'm going to call this P and P. And then down here, I'll do panel equals P. And here I'll do P. And then I'll go ahead and reload my function. There we go. That's better. And so now I can do like, let's do C. So we've got that separate title, right? And we can see that the legend changed. And then we can do D, and again, the legend changed, but not quite right. And so that's the one with the toxin. So I wonder if I screwed up things in my label, or in my factor, probably, right? So I call it tox. Here I call it toxin. So I think this should be tox, not toxin, right? Because there is no invader toxin, it's invader tox. All right, try that again. This should be better behaved for D. Except it's not. Where do I use toxin? Oh, no, that's F and G. All right. Okay, so we have some detective work to do. Oh, so here I've got invader toxin. That should be invader tox, tox. All right. Now let's try again. Get that to work. Cool. All right. And then last but not least, E. And that works. Cool. All right. So now we want to use patchwork to pull them all together. We can do that with the plus sign. Oh, I didn't want the plus sign at the very end. Not yet, at least. And there we go. Looks horrible, doesn't it? I could use my map to danger of not being dry. I know. But what are you going to do? Yeah, I think this is dry enough. So we've got our 4-panel figure. One thing I'm thinking about, of course, is the placement of those legends. I want them gathered together, and I want them on the right side. And so if I remember, this is in plot layout. And then I think I can do guides equals collect. This is purely from memory. We'll see if I got it. So it put them all to the right, and they're all different. Rats. So that's a pain in the butt. All right. Not sure what to think about that, to tell you the truth. Especially with the time we have left. And I think it's because we've got 4 different guides in the 4 different things. And I had hoped that by doing my trick here, I guess it wasn't much of a trick, with scale fill manual and scale color manual, that would have left the values in. But again, it's dropping those out. And I have one last thought. If we do breaks with the names of these, so as much as I gushed about the suggestion to do these named vectors, my normal approach would be to use the breaks. So I'm wondering if maybe it hurt me in this case to not use it. So we'll go ahead and put breaks in here. Let's get that loaded. Oh, and I must have not put them in quotes. All right. Quotes, 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 quotes. No errors. Nope, it didn't do it. All right. So That's a stinker. I want to get that to work. So I'm going to comment these out for just right now and look at panel B. Again, what I want is for it to show up here. And so I think what I could do would be, if I do like guides, and it's been a while since I played with the guides function. So forgive me for looking at the help, but I've learned to ask for help. So I think we want, oh, what do I want? So I know I want to like do like the overrides AES. Maybe guide legend, override AES. I know that's what I want because I want it to use the aesthetics that I want. And so it's telling me if I look down at the examples, I'll be in good shape. So I will trust you. And let's see. Not sure that I see it. Okay, let me try this. So let's do color equals guide legend, override AS, and then I will do list shape equals 21. Oh, bother. Huh. Anyone got any ideas here for me? I need to phone a friend here. Let's go to Google. So ggplot2 show in legend conditions, not in plot. All right. Oh, where'd that go? This Reddit. I don't find that the Reddit links are super useful. Ah, this is exactly what I've got. Let's see, does this help? So this is from a year or two ago. And I don't know. It doesn't really help. At least I'm not seeing how to help it, how it'll help me. Okay. So this is a couple years old. Let's see if that will work. Below is one way to combine and show all categorical variables for two plots using the patchwork package. So they're saying scale drop equals false. I'm using drop equals false, right? Yeah, and there. And I've got it set as a factor. And so it's showing up, but the marker isn't showing up. The calls being undefined causes your all right. Kind of rushing here because I'm looking at the clock and I have like 10 minutes And if I can get this one thing, I will be pretty happy. Let's see. This is the documentation for that. Oh, this is painful. That's really old. Let's go back to this. Okay, I have two plots with different ranges. I want them to have the same legend with the same colors associated. Okay. Okay. So they combine them with patchwork. So maybe setting the color outside of the function. It seems like as good an idea as any. And I'll get rid of this guide statement. So we'll pull that out of the function, get that loaded. And then there's an ampersand, that. Let's see if this works. Oop. Oh, I've got this plus sign at the bottom. All right. Let's make this a plus sign again, and we'll see if this works. Oh, maybe this doesn't need to be an ampersand. Nope, that didn't work either. Rats. All right. I'm sure this makes for really horrible viewing, but it's really, really annoying. So I'm doing kind of what they said. Let me take out the scale fill manual. Actually, let me take out the scale color manual. Comment that out. Yeah, that doesn't. So that's setting first and last. Yeah, I'm not sure. I think one other thing I'll try is the star. Oh. Star and star. Yeah, and that doesn't collect them. All right, I think what I'm going to do is go ahead and for now, I'm going to go ahead and put these back in the code. I'll get this to work again. All right, so I've I think have that. Okay. So I think what I will do for the time being is add to this legend position equals none. I'm going to turn off the legends. And there we go. So what I will do is I will post. I'm going to set that aside for right now, just because I feel like I'm feeling very naked sometimes when I make these videos. You're all watching me do what I do, and I'm not sure what I'm doing wrong. So I'm going to set this aside for now. And when you look at the code that's on the website, I hope to have the corrected code up, and I will maybe draw stars around it so you can see. But what I want to do is maybe take this the rest of the way and trying to make it look a bit more like the original, right? So like, so how would we do that? So a couple things occurred to me, is that it's adding space at the bottom. And so here we can also do like theme equals, is it theme or panel theme? No, I think it's theme. Theme equals theme. And then we'll do like plot.margin equals margin. And I'll do zeros all the way around. Nope, that wasn't what it wanted. Let's do plot layout. Plot layout. Okay, it's not theme. I had it down here at the bottom. So let me look at that. Plot annotation. Okay. Where were you? Back up here. Okay. And let me see what I do. Yeah, I did that. Okay. So this should work. So that kind of removed that extra border around things. I would like to have a little bit of extra space in between these. I know there's a way to do it within Patchwork to kind of set the column widths and spaces. I'm gonna, for the sake of time here, go ahead and do that within plot margin. Maybe I'll take this on the right up to 8 and the left up to 8. Again, there's many ways to do it within R. So we'll do that. And then I think my text, I want to match the size that I had down below. And let's see, here I had all this axis text. And I'm going to go ahead and copy this stuff down, or up, as it were, to my other function. Where'd I put you? Back up here. And this is fairly not dry, right? Because I am copying this stuff over and over. Within Patchwork, know that there is a way to use the same theme elements across all your plots, which is really what I should be doing here. But again, I'm trying to rush to get you something that looks kind of like the original, albeit without that legend. All right. So that shrank down the text a bit. I think that time on the x-axis, I didn't have that for the y. Sorry, I didn't have an x-axis below. So we're going to use the same size. There we go. And so then these titles and the cartoon now are a bit big. So we could come back up to our geom-rich text. And so where we plot the text, which was up here, we could go ahead and do size. And again, this is going to be in millimeters. So if I look at my ruler, actually, I can see how big theirs are. Oh, they're like 2 millimeters. So let's go ahead and do 2. Okay, so that, yeah, amazingly, that like matches theirs pretty well. We could go ahead and shrink down the size of the cartoon a bit. And, oh, yeah, I did that back up here with this geom-rich text. And, or actually, I did that up where I was defining this, right? So let's maybe make that 30. And that shrinks that down. So I think that looks pretty good. Kind of one thought I have with these y-axis titles is that they're kind of close to the text. And so maybe what I will add, so my axis title y, let's do margin equals margin r equals 3. So I think that was the default. So let's make it, say, 6. There we go. That got us a little bit of space between that y-axis title and the text. And again, I think, I don't know, let me know what you think. So again, we can make these plots the same size, and then we can compare. Right? So theirs is on the left, mine is on the right. One difference with mine is that I'm using that full width. If I could have figured out this legend a little bit better, then I would have put that over on the right side, and then that would kind of pull everything over. Again, if I turn this off, you can get a sense of like how big that would have been. Like that. So I kind of like those panel sizes, and that looks pretty good. The legend on the right is kind of garbage. Also, I'm noticing that my cartoon is kind of getting close to my points here. Why don't I go ahead and move that up? So back up in my geom rich texts, my y was this. Let's make that maybe 4 and 4e to the 10. And so that didn't do much. Let's make it 5 and 5. Let's do 6 and 6. There we go. So I think that's probably about as well as I'm going to do. And there is a bit of extra space at the top. So maybe that margin I could shrink a little bit. So that's my plot margin. The top put to 30. Let's make that maybe 25. Yeah, so I think that looks pretty good. Again, the problem is this blasted margin over on the right. So Mike says, can you drop the unused values? That seems more consistent with the example you showed. I could try that. Let's try. That's the default. And my understanding is that the collect in Patchwork only works if the guides are identical. So like we get that, right? So that's better. I mean, well, it's not really better, but it is what it is, right? So we're so close. Okay, because I didn't get it all the way, I will add one more element to this. And that would be, oh, where did I put you? All right, right here. Plot annotation. Let's come back to the help tag level. And we'll do A. And so we get those letters, right? But they're putting it in the margin. And so let's see. So then like in theme, we'll do tag dot position. Oh, I put tax, tag position, and let me look at the help for theme, because I don't do a lot with tags, and so oh, it's plot dot tag, I think. So let's come down to plot tag, and where are you? Plot tag position. So the position could be like an XY coordinates, but we want plot tag location also. And we don't want margin, I want plot. I believe. And then I'll make this a vector. I'll do like 0 point, let's do 0 and 1. And so that got us some space. And so let's move that up. So let's do like 1.05. We can go higher, 1.1. And I don't think it's using my font. So let's do plot.tag equals element text family equals Nunito. Maybe it was. Yeah, that must be. Okay. All right. I'll go ahead and remove this then. And let's make that 1.2. Actually, it could be bolded. So I'll go ahead and put that back in. I'll do face equals bold. And let's do 1.2. That's too high. All right. 1.15. So it brings that down. And yeah. So I'm pretty happy with the way that looks. Again, the one thing that sticks out to me that's a problem is this blasted legend. I will have to do some sleuthing on my own. Let me go ahead and put these back to be the same size. So for some reason, I somehow lost some of that aspect ratio, but it's pretty close. Yeah, so this legend is going to confound me, and I don't quite know what's going on, but I will get that figured out before I finish. Sorry, one last thing. So tag level, I think there's also a tag... tag levels. So I think I could do a list, if I recall. List B, C, D, and E. Yep, and I forgot the closing parenthesis there. Get out of that. There we go. We've got, well, I lost them. Oh, bother. Let me look again. Let's see. That was in plot annotation. And so tag levels. A character vector defining A for uppercase. Boom, boom, boom. All right. Maybe I can start with C. All right, this might be another thing I have to come back to. Ah, my gosh. Oh, I know what it is, I think. Famous last words, I know what it is, right? So I think I have to give list a vector. So we'll do B, C, D, and E. I forgot a parenthesis. All right. Oh no. All right, let me try this again. There we go. We've got B, C, D, and E. So to start at a non-standard location like A or 1, you give tag levels a list, and the list has to have a value of a vector. So which is what I did here, right? So anyway, I will stop there. I appreciate you indulging me on this. I did not think this was going to be as hard as it ended up being, but hey, here we are. And really, the only thing I didn't get was this legend, and I suspect if I go look, it is going to be like a one line of code. So I will put maybe a note in the comment the top comment of this video if you made it this far, telling you what I did to figure that out. And the code that I post to the blog post, which will again be linked below, will also have the correct code that includes all that stuff. And as I mentioned earlier, not to shill for myself too much, if you are interested in improving your data visualization skills in 2026, again, not for coding, but thinking about kind of the design of figures and kind of more of the types of things that I talk about in the critique videos, this is the workshop for you. It will be offered on January 9th from 1 to 4. Reach out to me if you've got any other questions about it. The link I did put there in the comments. Otherwise, I will see you